So I am P. Sradhabalan, Rohini College of Engineering Technology. Subject Strength of Materials. Subject Code CE3491. Regulation 2021. Today topic Spring. The spring are the elastic bodies which absorb energy due to resilience. The absorbed energy may be released as and when required. A spring which is capable of absorbing the greatest amount of energy for the given stress without getting permanently distorted is known as the best spring. The two important types of springs are laminated or leaf spring, helical spring. Classification of spring. Based on the shape, behavior obtained by some applied force, spring are classified into the following ways: spring, helical and leaf spring, helical spring, spiral spring, torsional spring, tension, and helical spring, compression, helical spring. Then helical spring, it is made of wire coiled in the form of helix. Cross section, the circular, square or rectangular. Then classification of helical spring. Open coil helical spring or compression helical spring, closed coil helical spring or tension helical spring. So characteristics of helical spring. So it is stretched upward to great load. The gap between the successive coils is small. The wire is coiled in a sequence that the tan is at right angles the axis of the spring. The spring is loaded along the axis. By applying the load spring elongate in action as it mainly depends upon the end hooks. So that is the helical spring diagram. So next application, the carriage door assemblies, and second point vice grip filers, and third point carburetors. Then helical compression spring, that is the characteristics. It depends upon the the gap between the successive coil is larger. It is made of round wire and probably in cylindrical shape. There are follows plain and ground end, square end and square and ground end. Then torsional spring characteristics, it is also form of helical spring, but it rotates about an axis to great load. It releases the load in arc around the axis zone in figure. That is the torsional spring figure. Then mainly used for torque transmission, and the application of the torsional spring, mousetrap, rocker winches, door hinges, clipboard. Then spiral spring, then that is characteristics. It is made of a band of steel wrapped around itself a number of times to create a geometric shape. It is inner end is attached to an arbor and outer end is attached to a retaining drum. Application: alarm timepiece, watch, automatic seat recliners. Then leaf spring. A leaf spring is a simple form of spring commonly used in the suspension vehicles. This characteristics: the center of arc provides the location for the axle, while the tie heavy vehicles leaves are stacked one upon the other to ensure. Then advantages: it can carry lateral load and provide braking torque. It takes driving torque and withstand the shocks provided by the vehicles. The spring materials. Mainly used the materials for manufacturing the spring are as follows: hot drawn high carbon steel, oil tempered high carbon steel, stainless steel, copper or nickel based on alloys. For phosphor bronze, iconial, monial, titanium. The problem: a leaf spring carries a central load of 3000 Newton. The leaf spring is to be made of 10 steel plates, 5 cm wide and 6 mm thickness. If the bending stress is limited to 150 Newton per mm square, determine length of the spring, deflection at the center of the spring, and E is equal to 2 into 10 power 5 Newton per mm square. Given data, central load of W is equal to 3000 Newton, number of plate N is equal to 10, width of each plate B is equal to 5 cm, that is the converted to mm, so 5 into 10 50 mm. The thickness T is equal to 6 mm, bending stress sigma is equal to 150 Newton per mm square, and Young modulus of symbol of caps E 2 into 10 power 5 Newton per mm square, and L length of spring and del deflection at the center of spring. So find out the sigma, find out the length of the spring. So that is the formula sigma is equal to 3WL divided by 2NBT square. Substitute the all value. So length of the spring answer is 60 mm. Then next to find out the deflection at the spring. So del is equal to sigma L square divided by 4ET. So sigma value you know that 150 into 600 the whole square divided by 4 into Young modulus of steel 2 into 10 power 5 into 6. So final deflection of the spring answer 11.25 mm. Thank you.